Hey there. How are you?
Doing pretty well. How are you?
I'm good. How you doing managing all of your other classes and so on?
It's been pretty crazy so far, but yeah, I'm getting it now. Now that
Yeah,
I'm
got an organized plan now.
yes, thankfully.
So let's kind of look. I'm guessing people will kind of jump on and off if they have questions, but um, do you want to talk about the sequence and series stuff or questions related to the online quiz? Where you want to start?
I actually had questions about number 93 and number 95 on the 9.3 homework
Okay.
because I get that we're using nth term on that, but I couldn't figure out
Right.
like how to get to 1 and E on those.
Okay. Okay. On 93, yeah, you're doing the limit and it's you're going to use horizontal asymptote rules where you compare the degree of the top and the bottom.
Oh yeah. Uh-huh.
So on the bottom, the square root of n squared is actually just an n.
Okay, yes, yes.
So that's why they're the same degree. And then when you do the coefficient, it's going to be the 1 on top, and then on the bottom, it's the square root of 1, which is still 1.
Okay.
And then 95, oh, good look there. Oh, there we go.
Okay, now we're there.
Did I lose Claire?
Hello?
No, I'm still here.
Okay. Oh, that's weird. Okay, hold on. I need to fix that. There we go. Sorry. Oh, we got lots of you guys. Okay. We were talking about 93 and 95 on the 9.3 homework. On 95, we're doing nth term test, but the way it looks, it's that formula for E. So remember, whatever goes in, let me get my pen here, whatever goes in this slot, it's like e to that power. So that one's going to equal e to the first. If that had been a 2 over n, then that would equal e squared. So when you do the limit of that, it just equals e to the first, which is not 0. So nth term test is a diverge. That make sense?
Yes.
So I was talking to Claire about number 93. Are you guys okay with 93?
Not particularly.
Okay. Let's look at that real quick. Hey, Claire, can you explain to them 93 what we talked about, why we're going to use the nth term test and how it works?
Sure. For 93, it was just the horizontal asymptote rule. So you would get 1 on the top, and then when you take the square root of 2n, that's just 1 on the bottom as well.
You mean the square root of n squared?
And squared, whoops. Yeah, that's what I meant.
Are you guys okay with that? That's why it's the same degree, so you just look at the coefficients?
Yes.
Okay?
Yes.
Okay. Got to jump up and down, yell and scream if you have a question. So we're okay on 93 and 95? What about, are there others from 9.3 that you guys want to talk about?
Can you talk about 97?
97, yeah. So if let's look at it two different ways, okay? Remember the very last one that we did in the notes, I think it was, where we did 1 over n and then natural log of n? And we said that one was a converge. No, I'm sorry, that was the diverge.
Right.
Remember that at all?
Okay. Yeah.
And we did I think we did the integral test on that, where we did the integral and we let u equal natural log. And by the way, I could do the same thing on this one, where I could do the integral test. If I integrate 1 over n and then natural log of n cubed. And if I let u equal natural log of n, well, I'm sorry, when we write it as an integral, we're supposed to do a function of x. Not that it matters, but so I'll write x, natural log of x, and so u. So if you take that all the way through, basically you'll be integrating 1 over u cubed, or u to the negative 3. And then when you plug in your 2 and your infinity, you'll actually get an answer. And I can take you through that if we need to, but you'll actually get an answer. So the integral test works, which means it converges. But did you guys catch on at all to that last part that I was talking about, where we kind of start to compare everything to 1 over n?
Yes.
Mm-hmm.
And so if 1 over n times natural log of n, that one was a diverge. And so I think what we said was the next one that we had done in the notes was like a 1 over n squared. I can't remember for sure. But basically, if the numerator grows any faster, I'm sorry, if the denominator grows any faster than n, natural log of n, then it's going to switch over to be a converge. And so do you see that n times natural log of n cubed is going to grow faster than n times natural log of n? And since it grows faster, it's going to be a converge. But again, if you don't understand that last part, if you do the integral test, you'll actually get an answer. Do you guys need me to take you through this integration?
No.
Sure.
Hey, what the heck? We got nothing else to do, right?
Mm-hmm.
Has anybody been to the grocery store at all?
Quarantined.
Yeah.
Nice.
Not for like the past 2 days.
Oh my goodness, you guys have such sad voices in your quarantine.
That's what happens when you don't see your friends for this long.
Well, you're saying me now. You should be happier.
It's not the same. We don't get back when it's over the screen.
Luke, I have to tell you, we had I think it was a department head meeting. I don't know whatever, right after we had my meeting with you guys.
Mhm.
And we were just talking about, if we've seen the kids and what all. And I said, oh yeah, even remotely, they make me feel old, because I told Luke that he looks like Grizzly Adams, and he said, I don't know what that means. They all. So anyway, I'm still using you. Okay, so if we take this through, I'm going to, if u is natural log of x, then what is du?
X.
1 over x
Or
dx.
X, D.
X.
There we go. And so let me move this up for us. Yeah, still the magic happens. Okay, so that means that dx is going to be x times du. And so can you tell from that that when I replace the dx that was up here, when I replace that dx, can you tell that this x is going to cancel with this one?
Yeah.
And so what I'm really integrating now is just 1 over u cubed. I'll bring in the 2 and the infinity in a minute. Good there? Yeah, we are, Miss Napier. Thanks. Okay, so if I integrate, I'm thinking of that as u to the negative 3, right? So if I integrate u to the negative 3, so let's see, u to the n plus 1 over n plus 1 would be u to the negative 2 over negative 2. So what we actually have here is negative 1 over 2 u squared. Now, I could either change my 2 and my infinity into u numbers, or I can just change that u back to natural log of x. Okay, how about I just change it back to x? So I'm going to think of this as negative 1 over 2, and then in place of u, I'm going to put natural log of x, so it's natural log of x squared. So that's what I'm going to evaluate from 2 to infinity. Okay?
Mm-hmm.
Donovan, where are you?
I am at my dad's office because our Wi-Fi went out.
Oh, look at you being resourceful. Woo! I just saw those lights or whatever that is above you. I thought, what is he doing?
There are lights. Yeah, it's very exciting.
Well, it is very exciting. Okay, sorry. So if I put in my infinity, well, there they go. Hello. Shush. Okay, seriously. can you see how let's see, am I around? Can you see how he's like standing on the back of the chair? Oh wait, all right, I can't get it without unplugging. Sorry, never mind, you can't see it, but he is. Okay, I would compare him to a cat, but I do still love him. All right, I put in infinity, that's gonna just be 0, yes?
Yes.
Yes.
And then minus, if I put in 2, it's going to be negative 1 over 2 natural log of 2 squared. And I don't even care what that equals. The fact is, it is a constant, right? So it does not equal infinity. It actually works, which means that's how I know this is a converge. Okay?
Okay.
I hate to point this out to you guys, because now it's all you're going to notice. But when I was making the videos last week, and I don't know, in making them, I would go back and watch them and put in questions for the other classes and that kind of stuff. And so I was forced to listen to myself a lot.
Mm.
And I realized I have turned into Dan Panetti. In the videos, I say right all the time. Oh my gosh. I felt bad for making fun of him. I thought if I were you, I would start counting my times I say right. Oh my God.
Quarantine changes a person.
I know it does. Makes you learn a lot about yourself that you never wanted to know. Okay. What else? Any from 9.3?
Mm-mm.
Are we allowed to ask questions from the online test?
Yeah, well, are we good from 9.3? All right, so you can ask questions, but I'm not going to give you like specific answers. I can kind of give you hints and that kind of stuff. All right. So here's my questions. All right, which one?
That's a lot of answer choices.
I thought you'd appreciate that. Which one, Annie?
I mean, which one do I not have questions about is
Okay.
probably the better question.
Well, I do need
Oh, wow.
specific questions because, you know, this is a
Okay,
test grade.
Yeah, I noticed. For the first one, how do you want me to demonstrate that on a piece of paper? Like, I just don't know how to communicate that to you other than like just
Oh, you
draw.
don't. Yeah, some of them you don't have to communicate anything. I
So,
only
like,
want
that
you to
one,
turn
I
in
can
work
just
for the
pick
ones
an
that
answer?
kind of require work or require setup, that kind of thing.
Okay.
For this one,
And
you just select an answer and you're fine pretty much.
Yeah. And I
Okay.
forgot what I have showing here. I actually deleted a couple questions. I can't remember if it's number 1 that I deleted or if it's number 2 that I deleted. I know one of them's there. Anyway, so yeah, you just pick the answer, and remember, you get to use your notes, so you can go back and look at that stuff that we talked about and what determines if it's left or right, what determines if it's up or down, you know, what determines if it's got the little, you know, loopy thing as opposed to like this one that has like the indentation, or, you know, we did some that were like that. Remember how we talked about we talked about all the differences and that kind of thing. So just look at your notes. You know, what determines where it hits this axis, what determines where it hits over here, that kind of stuff. I think the graph one, if you just look at your notes, you should be okay.
Okay.
All right, no work required on that. Come here. Yeah, good dog.
Question on, I think it's number 4 for you.
I am at school. What?
I have a question for number 4 on yours. I think it's
Okay.
number 2 on our quiz.
Yeah, the numbers are going to be different because, like I said, I adjusted since I printed here. So on this one, you want to make sure you present your answer as R equals. So if it says, Milo, shut up. So it says you want your answer in polar form. So make sure when you type in your answer, you type in R equals.
Okay.
There's 2 ways to do this one, I think. So you could use those formulas that we talked about, like X equals something in polar and Y equals something in polar, and you can look in your notes and see what that is, right? So you could always just put that in and then do all the math and solve for R. It's going to be a pain. What I did, here's my hint, what I did was I just said, hey, I know what that's the graph of in this form, and I graphed it. I looked at the radius, I looked at, what the center was going to be. And just by looking at the graph, I could tell, oh, I know exactly what that should be. That's one of those special kinds of graphs that we're supposed to know. So you can either plug in, multiply it out, solve for R, or you can just kind of think about what that graph should be and then come up with what that equation is.
And if we graph it,
I have to
we
go
won't
smack
have
my
any
dog. I'll be
work,
right
right?
back.
Poor dog.
I couldn't do it. How could you smack that face? Look at him. Look at him.
Aw.
Okay. All right. Does that give you at least a hint on that one?
Yeah.
Okay.
Yes.
All right. What else?
Mhm.
How many of you have looked at it yet?
I'm too scared.
Don't be scared. Did you all understand the directions that I gave? I set it up so that when you open it, like you can work on it for a while, and if you need to like go do something, it'll allow you to save your work and then come back to it. So it's not like you're not starting another attempt, but you can still come and go as long as your total active time is not more than 24 hours.
Okay. Can we like exit out of the page and it'll be fine? Or like if I
Yeah,
can
yeah. I think if you save your progress, and I think you can still exit out of the page and then reopen it. If for some reason that doesn't work, let me know and I can, let you back in. But I'm pretty sure it'll let you do that, assuming you save your progress.
Mhm.
Yeah.
Does this do at midnight?
Tomorrow.
Okay.
I think I
Is
put
the
10
AP
p.m.
exam really online?
I think I put 10 p.m. tomorrow. What did you
Okay.
say, Matthew?
Is the AP exam really online now?
Yeah, and I was going to talk to you guys a little bit about that. It's online. It's 45 minutes.
Oh,
Which,
instead of 3 hours?
Total?
yeah, instead of 3.5 hours, it's total 45 minutes.
No free response?
It's all free response.
Oh, really?
Oh, wow.
Oh.
And that's all they've told us so far. They're supposed to give us more information by April 3rd. But the thing is, when they say free response, I don't know if that means like what we think of as free response, where you have, hi,
Kevin.
where you have like, a stem of the question and then a part A, B, and C or something. I don't know if it's going to be like that, or if it's like maybe the old days kind of tests where, where you just have a whole bunch of problems and you have to show your work to present your answer.
Are they
And I
gonna
know
have
the
That'd be
us,
good.
grading is going to be
uploading
all
pictures?
online also. Do what?
I feel like this would be like 2 free response questions, so.
Are we doing this on paper and taking a picture, or are we typing our free response?
Well, again, I don't know that much yet. I think there's going to be options. The way it reads, and I can kind of send you the little snippet if you want, but the way it reads is it's a 45-minute free response. I think there'll be different ways that you can submit it. And it did even say, even if they do work on paper and submit, the document or something, but like I said, we don't have any specifics yet. They did mention that might be an option.
Also, what topics did they cut out?
Okay. Well, I don't want to tell you until tomorrow
Oh, okay.
Ah.
because they cut out all of parametric and polar.
Let's go.
I can't believe you asked me that. I
Can
intentionally
this
did
test
not,
be a free 100?
which
Yes.
is why I don't feel bad about making this test be, an online test, and you get to use all your notes and everything. So, I mean, if you have to take any math classes, it's good that you've seen it, but we'll do this online quiz and then be done with it. As far as sequence and series, they've cut out some parts of it. So from what I can tell, that means we're going to have to do 3 more sections in sequence and series, and then we'll start reviewing. So on one hand, it's frustrating because when you have a really good BC class and you've gotten as far as we have, I would kind of like to be compared to all those losers who didn't. And by losers, I don't mean students, I mean teachers, you know, who didn't get you to this point. But we could just think positive and say, well, hey, we only have to do 3 more sections, and that's going to give us more time to review. So either way we look at it, I do feel really good going into an AP exam. With the amount of time that we have left and with, you know, how we can set up review, I think we can very much make from here on out be not like killer amounts of work. I'll kind of organize a plan so that maybe if you even just devote, you know, say an hour each A day total, I think we'll be very prepared.
Do we have to take it?
Yeah, why wouldn't you?
Ben
I
Owen
don't
wouldn't take it.
like
He doesn't
it.
need to.
You've done so much work for it. Why would you quit now when I'm telling you that it's not going to take all this extra. If we devote an hour each A day, we'll be fine. You got nothing else to do.
That's true. That's very true. I'm very bored all the time.
That is very true.
And this is your way of keeping you connected to me. So, I mean, come on. How can you
Couldn't
snub
we
your
just,
nose
like-
at that?
We could Zoom and talk about your dogs
Real
instead. Be a lot more fun.
What, Gavin, we're not done with that. We're not doing it. We're talking about it then. We're talking about it then.
So, like I said, when I know more on April 3rd, I'll, I might tweak, you know, what we're doing. But basically what I'm doing right now is over this weekend, I've been looking at it and thinking, okay, if I were the one that was going to, you know, make this test now in this new format, what would I put on it? And so I'm kind of going back and pulling out what I consider are, you know, like the must knows, the most basic. Like we'll go back and we'll review mean value theorem, and, you know, absolute max and min, and, you know, just some of those things that I know that you can do that will just kind of hit the basics. Okay? It sounds like,
Good.
as far as this parametric and polar, it sounds like it's the kind of thing where you need to kind of look at it and jump in and, you know, like just kind of have your notes there and start looking at some things and trying some things. I'll mention this. I'll tell you this. So we talked about the converting back and forth. On problems like this number 5, the slope of the line tangent to the curve. What's another word for slope of the line tangent to the curve?
Derivative.
Derivative. So they're asking you for dy dx. And we talked about the definition in parametric for dy dx. So just look in your notes at that definition. And really it's, and then you can use your calculator to do any computations that you need.
Is this all calculator?
I think I've labeled, so anything that has, you know, answers like there with the decimals are all calculator. So like I want to see setups of what you would put in your calculator.
Okay.
But as far as any simplification or like when you get down here to, let me see, when you get down here to problems like number 9, what's the total area between the polar curves given below? So I want to see your integral setup, but then you can put the whole thing in the calculator to get your answer.
Awesome.
So like on this problem, tell me this, you guys, 5 sine 3 theta, what kind of polar graph is that?
It's like a rose or whatever.
3
So
petals.
it has
Like-
petals, right?
3 petals, length 5.
3
Okay,
petals.
so 3 petals, length 5. So here's my
There we go.
5. So how would that be
Beautiful.
different than 8 sine 3 theta?
3 petals, length 8.
And wouldn't the petals be in the exact same place because they're both sine?
Mhm.
Yes.
So it's going to be this kind of thing, just longer petals, right? And so what are they asking you for? What is the total area between the polar curves? So I want this area.
So is it just 8 sine 3 theta minus 5 sine 3 theta?
It is subtraction, but I'm not going to give you the answer, but you do need to go back and look at the formula for area. It's not
Well,
just like top
it
minus
involves
bottom.
tangent lines and stuff.
Well, okay,
It
hold that thought. So
involves-
based on what Anna was saying, it's not just 8 sine 3 theta minus 5 sine 3 theta. You got to go back and look at the formula for area, okay? There's other stuff involved. But the important thing is you can either do one petal and then multiply by 3, or you can kind of think about the whole thing. What you have to be careful with on this one is, let me just ask you, to graph one full graph, do you think it would be from 0 to 2 pi or what? Because you can't just assume that. You could always
Well, you
play around on your
multiply by
calculator
3.
and say, like here's what I did. When I first looked at it, I thought, I'll just do one petal and multiply by 3. So if I just did one petal in my mind, it was going to do from here to here. But when I actually graphed it, and I graphed from 0 to pi over 2, it did this much. And that's more than one petal, right?
Mm-hmm.
So you either have to figure out how far is it just for one petal, and you're right, Donovan, that's where the tangents at the pole would come in. You could do that. Or you could say, well, how long does it take to graph the whole thing, and just do that total and not have to multiply by 3. So those are the little subtlety things you're going to have to think about for number 9. Does that help?
Yes.
Whereas if you look at one like, look here at this crazy one, number 12. Well, it's my number 12, might not be yours. Just looking at it, it makes you think it would be from where to where.
0 to 2 pi.
0 to 2 pi.
Right. So make sure you plug this in polar mode and graph it from 0 to 2 pi to make sure that it takes 0 to 2 pi. And it might. I'm just saying, you know, you got to check it and make sure. Because if it is 0 to 2 pi, it's pretty straightforward.
Mm-hmm.
Like old nurses can reactivate their licenses.
On this one,
Oh, woof.
whoa.
What in the world?
So the first thing we have to figure out is which curve is which, because I have two curves. I have this one and this one, right? So you can put that in your polar and see which one's which. I actually, on yours, I might have even labeled which one was which. I can't remember. Anyway, do you remember, Anna?
Sorry, what?
On this
remember what.
particular problem on the online quiz, do you remember if I actually labeled which graph was which?
You did not. I'm
Okay,
looking at it right now. It's number 11.
Okay, I couldn't remember. So, but you can do that on your calculator. You can figure out which one's which, right? So on this one, it says that they intersect at 0.8. So that means right here is theta equals 0.8.
I mean, ideally, when it comes to the harder nursing stuff, other than
So on this one, we're going to have to figure out how to set it up. Do you think this would be one integral or more than one?
One.
Probably more than one. Maybe between the theta equals 0.8. Between like the lines, so one on one side, one on the other side of the line.
Yeah, I'm thinking that this side is going to find me one set of area because that's going to be using this curve, right? And I'm thinking
Right.
that probably this side
really, really
using this curve is going to find me the other. So you're going to have to figure out, like for the red section, okay, where should I go? Is it going to be 0 to there, or, you know, what's the tangent at the pole here? And for the blue side, you're going to figure out, okay, yeah, I know I'm going from 0.8, but how far? Does it go to pi over 2? Or in other words, what's the tangent at the pole on the blue side? So you're going to have to think about the two separate parts. And the other thing to keep in mind on this, yes, do your setups, you know, and plug it in to get your answers, but you're going to submit your work. So I'm looking at your work also. So even if you get the wrong answer, I'm still grading partial credit on, you know, the setup and different things like that.
How many questions is this?
What is it, Anna?
18.
18.
Okay. And say I start at like 8 p.m. tonight. I just have to turn it in by 8 p.m. tomorrow. So it's 24 hours.
Well, you
It's
just
23.
can have it open for 24 hours. If you start at 8 p.m. tonight and you work on it for 2 hours and then you save it and you close out and then you start again tomorrow at 10 a.m., it's just a total of 24 hours that the quiz is open.
Okay.
Oh, wow,
yes.
that's a lot of time.
Yeah, I didn't think you would
Very
need 24 hours to do it. I just did that so you'd have plenty and it wouldn't be an issue. Because I knew some of you guys are big on opening it and then leaving it open. I'm just going to caution you, since you only get one attempt, if something happens and you lose your internet connection, it's going to automatically submit it.
Yeah.
So save your progress often, in case of those kind of things. Okay?
Okay.
Can we go up to number 14?
Well, I don't know if my number 14 is the same as yours. Is it this one?
Yeah, that one. It's number 12 for us.
Okay.
I'm not sure what this one is asking.
Okay, so this is vectors, right? So you have two components. You have your X component and you have your Y component. And so on this one, it's saying, I want to find G of 0. So you need to be thinking, in order to find G of 0, again, you're going to need to have your X component and your Y component. Okay, so two separate things. So my suggestion is look at them separately. So let's say we're just going to talk about X's. Okay, if I'm just talking about X's, I could say that G of 7, the X coordinate is square root of 2. Yes?
Mm-hmm.
So what formula could I write for, in general, go back to, AB, G of 7 equals what? G of
We were testing them.
0
Plus the rate of the amount of change.
amount of
Plus-
change from 0 to 7 of G prime, right?
Mm-hmm.
But look up here. Do they give me G prime?
No.
No. They give you G of T. So you have to,
Well, it says the instantaneous rate of change of G is this.
Oh, so that's G of prime.
Isn't that
that's
saying it's G
derivative.
prime?
okay,
Oh.
yeah.
So do you see by doing this, I'm going to get the X coordinate? And then do you see you could do the exact same thing, but use the Y values and you could get the Y coordinate?
So you have to separate them when you do that? Like do the X by itself and then the Y
Yes.
by itself?
Yes, because remember in parametric, X has its own equation and Y has a separate equation. Does that help, Katie?
Yeah.
It's not that
Okay.
one, but the other one's less.
I don't know what number it is on yours, but I think there's one that says slope of a tangent line and it's in polar. Remember, in order to find slope in polar, you have to think of,
Y over dx.
well, yeah, it is dy over dx. But remember, you for x, you have to think of r cosine theta. And for y, you have to think of what?
R sine.
R sine theta.
Right? So when you do your dy d theta, you're doing the derivative of this, right? And when you do your dx d theta, you're doing the derivative of this. Again, that's in your notes if you just go to the very beginning of the calculus part of polar.
I'm not sure which number it is for you. It's number 3 for us. It's the one with e to the t.
Okay. Yeah, it's
And it says x equals 3.
this one, yeah.
Yeah. Is that supposed to be t equals 3?
No, it's not.
Okay.
And you made a
we're
great
finding T?
observation. You made a great observation because when you do your dy dx, it's going to be in terms of t. And so you can't just plug in 3 for t. You have to go over here. You have to say, hey, if x is 3, and I know x equals e to the t, what does that mean t is?
Natural log.
Natural log.
Yeah. Good job, Katie. You just helped them out a lot with that one.
Wait, will you explain that again? I don't get what you just said.
So when it says to find the slope of the line, so that's dy dx, at the point where x equals 3, okay? Well, when you do dy dx in parametric, don't you do the derivative of y over the derivative of x?
Yes.
Yeah.
And so when you do the derivative of y, it's going to be in terms of t. And when you do the derivative of x, it's going to be in terms of t. So you're going to have this dy dx that has all t's in it. It's not going to have x's and y's in it. So when they say at x equals 3, you can't just plug in a 3 for t. So what you have to do is, if x is 3, you have to figure out what does that mean t is. And then you can plug the t into your dy dx.
Okay.
Okay? And then remember, on that next question, we had a separate formula for second derivative. And again, that is in your notes, that separate formula for derivative in parametric.
Can you talk about the one that has a particle moving along a curve xy equals 10?
Mm-hmm. So on this one, here's my thinking. The fact that they mentioned dy dt and they mentioned dx dt, I know that dy dt and dx dt are related. Whoops, I'm sorry.
If this works.
Let's see, they are related. Let me go back. Here we go. They're related in that I know dy dx equals dy dt over dx dt, right? And so I used that idea and I said, okay, I can plug in dy dt. I know dx dt is what I'm trying to find. And so if I could just figure out what the value of this is, then I would have an equation that I could solve, right? So how can I figure out what dy dx is based on this?
Y equal to 10 over x.
Yeah, you could just picture that as y equals 10 over x. And then if you do your derivative, your y prime, that is dy dx. And then, use your x equals 2. So kind of combine those two concepts and you should be able to solve. Okay? You guys that have looked at the quiz already, did I leave my number 8 in, the one with the K?
Yeah.
It is in there?
Mhm.
Okay. This one can be intimidating, but let me tell you this, on the one with the K. So you're given x prime and y prime, not x and y, but x prime and y prime. So you're given your dx and your dy. And then it says the line this is parallel to the tangent line. So what are they telling you with that?
That is the derivative at t equals 2.
Okay, so it's the derivative, it's the dy dx at t equals 2, right? So what is dy dx for t equals 2? Because this line is parallel to the tangent line. Doesn't that mean they have the same slope?
Mm-hmm.
So what's the slope of that line?
4.
4. So basically, when they tell you that that line is parallel, they're telling you dy dx is 4.
Okay.
But hey, wait a minute. What's the definition of dy dx in parametric?
Like think about all the small businesses.
dy
dt over dx over dt.
So that'd be the same as saying y prime of t over x prime of t. So there's the equation that they've given you right there for you to solve. And the reason I mentioned this one is because you're going to get to that point and you'll be like, oh my gosh, how am I supposed to solve this? Well, look at your answer choices. Use your calculator to help you solve it. Okay?
Mhm.
All right. I've given you, I think, some pretty good hints on lots of them, right?
Right.
Yes.
There's one that's the length of the curve. What's another name for length of the curve?
Arc length.
Arc
Yeah,
length.
so that's just a formula you can go look up, right?
They're completely
Um,
non-essential, like.
speed, isn't that another formula that we had? You can just go look up in your notes, right? Okay. So some of them are just formula ones. So I think I've given you hints on most of them. So I'm going to let you kind of try some things. You're welcome to, you know, kind of come back and gradually ask me questions, you know, I'll throughout today and tomorrow. You know, we'll try and answer questions through, you know, text or email, but if we have to jump on, I'll, you know, on Zoom or something, I can do that and kind of give you some more hints or, you know, help you through. I'm just not going to do the problem for you. Okay.
Yes.
Okay.
Do y'all feel like you have some things to try now?
Yes, ma'am.
Yes.
Okay.
Okay, we have no homework due next class, right?
No, it's just, I just wanted you to have the time to devote to working on this. The good thing about the changed test is it has freed up our time a little bit so that we didn't have to, you know, this be kind of an extra thing in addition to homework, that kind of thing. So aren't you more excited now about taking the exam, Anna? We're going to get you on board. We're going to get you on board. Okay?
Sounds
All right.
good.
Well, hopefully that'll do something for you guys, but you know, keep in touch. Let me know what else I can do. Okay.
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 Thank you.
Thank
All
you.
right. Talk to y'all later. Hey, Gavin,
Hi,
what are you doing?
I'm eating with my dad.
Oh. Hopefully you have something good for lunch.
Yeah, it was Macero takeout.
Ooh, that's good.
It is good.
So how is
Yeah.
online for the semester going for you?
It's kind of weird. Like I have 2 hours of online class a day, and then I'm just done. So just a lot of homework.
I was gonna say- So they're just kind of giving you a lot to kind of work on your own then?
Yeah, it's like everything is basically 30 minutes of teaching, and then all right, do 2 hours of homework, and yeah,
So
it's pretty boring.
tell Donovan he needs to suck it up and appreciate what he has then.
That's right.
Yeah, there's no office hours anymore, so it's it's not fun.
That's right. Hey,
Yeah.
there you go. You hear that?
Yeah, I got it all.
Although I guess you haven't been the complainer of the group.
Who has?
Nobody.
Okay.
All right. Well, hey, Donovan,
All
good to see you. Gavin, good luck this
Good
semester.
to see you.
You're going to do great.
Will do. Good luck with AP tests.
Oh, yeah, we'll be fine. We're going to be great.
Yeah, all fives.
All right. I'll see you guys.
Okay, bye.
Bye.